Examples. Solve using elimination in this case. Keep in mind, you could always solve using substitution as well for most or some of this as well. Okay, remember the steps. Step 1, get them equal and opposite in sign. Step 2, solve for one of the variables, or add. Step 3, solve for the variable, and step 4, solve for the other variable. So let's begin with the first set of equations. We have 4x plus 6y equals 10. And let's write them one on top of the other. The other one is negative 6x minus 9y equals negative 15. And it's your choice on which one you want to eliminate. Agreed? But for reference, let's see. The top are positive, the bottom are negative. So either would work actually. So let's say we want to eliminate x. Just for reference, I chose x. Flip the coin, let's say. And that's how come I chose x. Okay, so that implies that 6 is not a multiple of 4 and 4 is not a multiple of 6, agreed? So I'm going to have to change both equations. In some cases, I may only need to change one of the equations, but in this case, I have to change both. So I'm just going to randomly select the 6 and the 4 because they are part of the x that I'm going to try to eliminate. So we're going to use the 6 up on the top one, just flip-flop the order, in other words, and the 4 on the bottom. There we go. And since they already have an opposite sign, I don't have to worry about opposite signs or putting a negative on the 4 or the 6. Because the bottom already is negative and the top is already positive. They're opposite sign already. So we're just going to distribute 6 times 4 and 6 times 6. And of course, let's not forget to remember to distribute to the 10 as well. 6 times 4, 24. 6 times 6, 36. 6 times 10, 60, agreed. So 24x plus 36y equals 60. And let's distribute the 4 also. So 4 times negative 6, negative 24. 4 times negative 9, 9 times 4, 36, right? And it's a negative. And 4 times 15, let's see, 4 times, 15 times 2 is 30, right? If I double that, that'll give me 60. Or you can go 4 times 15 to give you 60. Or check with your calculator, right? Quick check, couldn't hurt. So, hey, look at that. They're all equal and opposite. So let's try adding then. If we try adding, 24x minus 24x technically cancel each other out. 36y minus 36y technically also cancel each other out. And 60 minus 60 cancel each other out. What happened here? Well, they're all zeros. 0 plus 0 equals 0, so 0 equals 0. It's true, right? This is a true statement. They're both equal to 0 on both sides, so that implies that both equations are technically the same equation, except one might be a multiple of the other. So it looks like the second equation is a negative multiple of the other, so it's 1.5. So it's a negative 1.5 multiple. If you multiply 4 times negative 1.5, you should get negative 6. 6 times negative 1.5, you should get negative 9. And 10 times negative 1.5, you probably get negative 15. Try them out. So therefore, this implies that this is a dependent system. And I don't need to go any further. Meaning, they're always going to be the same. The solutions are always going to be the same since it's a line on top of the line or it's the same line. So in this case, it just depends on where do I want to know the value. Let's say at x equals 5, I plug in 5 and it'll give me the y value. And it'll give me the same value for both because it's the same equation technically, except it's a multiple of the other one. So let's go on to the next one since this is a dependent system. Okay, in this case, 6x plus y equals negative 13 and 3x minus 2y equals negative 19. And since in the previous one I chose to eliminate x, just randomly I'll choose to eliminate y in this case. And notice that it makes it easier actually in this case to be aware of that. If you already have opposite signs, it might be one choice. Because the y is positive and the negative 2y is negative, they're opposite in sign already. So I wouldn't have to deal with the signs. That's one choice. But do realize, I could also go with the first one, the 6x and the 3x, because 3 is a multiple of 6. So I would only change the bottom one. But I've already selected to eliminate the y value in this case. So let's put parentheses around this and notice that I only have to change one equation in this case. If I multiply 2 times y, that gives me the equal and opposite of the negative 2y from below. So I don't need to change the equation from the bottom. So let's distribute. 2 times 6 is 12. 2 times y is 2. And 2 times negative 13, negative 26. All right, there we go. So 12x plus 2y equals negative 26. So the second equation, I don't have to do anything with it because it's already equal and opposite for the y value. So I'll just copy it down. 3x minus 2y equals negative 19. And we could probably combine them. So we can add them. So adding them in this case, 12x plus 3x will give us 15x. And 2y minus 2y cancels out, so it gives us a 0. Don't need to bring it down since it cancels out. 26, negative 26 minus 19 gives a total of negative 45. And now choose off for x. Let's divide by 15. So dividing by 15 on both sides. There we go. 15 divided by 15 cancels out. And negative 45 divided by 15 gives us that x equals negative 3. Hey, look at that. There's our answer. Or one of our answers, I should say. So now let's solve for the y value. And you can select the one with the 6x plus y equals negative 13 or 3x minus 2y equals negative 19. In this case, I selected the top equation. So let's substitute the x value then. There we go. Replacing the x value. 6 times negative 3 plus y equals negative 13. And we're solving for y. So 6 times negative 3 gives us negative 18. And let's get rid of the 18 plus 18 to both sides of the equation. That gives us the y, in this case, equals 5. 13 plus negative 13 plus 18 gives us 5. Okay, so there's our second answer. And keep in mind, this is a coordinate point location, right? It's an intersection between two lines. So there is our answer technically, where they both intersect. So it's a consistent system with one solution, agreed? Let's try the next set of equations. But let's do notice, this next set of equations, they're not set up for elimination. They sort of, but don't look alike, actually. They don't look alike in reality. So let me work them out a little bit before using them for elimination. But we could probably use them with substitution instead. But since we're working on elimination, I use elimination. So let's convert them. I'll convert right below there on the yellow area. So converting them, let's copy the formulas down. The first formula, let's distribute the negative 5 into the 2y and the 3. So that gives us 7x minus 5 times 2 gives us 10y. And 5 times 3 gives us 15, negative 15, right? Which still equals 3 on the other side. So let's solve for, well, let's not solve. We're trying to get them to be set up for elimination, agreed? So let's get rid of the 15 to the other side then, since it has no variable. So plus 15 to both sides. So that leaves us with 7x minus 10y equals 18. It sort of now looks like it's ready for elimination, but the second equation isn't. So let's try the second equation. 4 times, in parentheses, 2x minus 7, close the parentheses, plus 3y equals 7. So let's distribute the 4 then. 4 times 2x, 4 times 2 will give us 8x, and 4 times negative 7, which will give us negative 28, agreed? So there we go, 8x minus 28 plus 37, plus 3y equals 7. So now let's get rid of the 28, that way we have just the variables with numbers on that side. So getting rid of the 28, it was positive, let's get rid of it, it was negative, so let's get rid of it by adding. So adding 28 to both sides. And now that leaves us with 8x plus 3y equals, and 7 plus 28 give us 35. Hey, look at that. Now they're both ready for elimination. So let's bring them back over to the right side over here. And let's copy them down. 7x minus 10y equals 18. And 8x plus 3y equals 35. And now let's choose to eliminate one of them. Hey, look at that. The y's are opposite in sign. So how about we eliminate the y's since they're opposite in sign? We could eliminate either the x or the y. Your choice once again. I'm going to eliminate that one. And 3 is not a multiple of 10, so therefore I have to change both of them. 10 is not a multiple of 3, obviously, because it's smaller. So, in that case, let's see, we're just going to use the 3, which is on the y, and the 10, which is on the other y. Opposites. So, do I need an opposite sign? No, I don't. They're already positive and negative, right? They're opposite in sign. So distribution, 3 times 7x gives us 21x. 3 times negative 10 gives us negative 30y. And 3 times 18 will give us 54. I recommend you try and check with your calculator. So once again, check with your calculator, please. Now that you've checked that we got it correctly, let's proceed on. And once again, 10 times 8 gives us 80x, 10 times 3 gives us 30y, and 10 times 35, 350, agreed? We're adding a 0 to that because it's a multiple of 10. Once again, we're going to try to add, and this is where we can verify. Do our y values cancel out? Yes, they're equal and opposite. One's negative 30, one's positive 30. Since they're equal and opposite, they cancel out. It gives us a 0. Agreed? So 21x plus 80x gives us a total of 101x. 54 plus 354 gives us 404, 404. And now let's get rid of the 101 from the x to solve for x. So divided by 101, divided by 101. And that gives us that x equals 4 divided by 101 is 4, agreed? So there's our answer, x equals 4. So now let's use one of the, well, we don't want to use one of the original ones. We want to use one intermediate in this case, because otherwise we would have to go back way, way before. So let's use the top equation for this case to make it a little bit easier, since it's a simplified form of the previous equations. So there we go, let's copy it down. 7x minus 10y equals 18, and let's replace the x with the 4. So 7 times 4 will give us 28. So we would have in that case 28 minus 10y equals 18. And now let's solve for y. So let's get rid of the 28 minus 28, equal and opposite on both sides. 28 cancel out on the left side. Negative 10y equals 18 minus 28, which gives us 10, agreed? So negative 10y equals negative 10. And now let's solve for the y, meaning let's divide by 10, negative 10, agreed? So let's divide by negative 10. 10 divided by negative 10 cancels out, and 10 divided by 10 gives us 1, or negative divided by a negative is a positive 1. So our second portion of our answer, y equals 1. And finally, the full answer, 4, 1 is our coordinate location. So it's a consistent system with one solution. There is our answers for this particular case then. And let's remember, we previously had something similar, agreed? This is where we're checking types of linear systems. We have consistent systems, which is sort of like the two answers that we last got. Basically, it's an intersection point of where two lines meet each other. Inconsistent systems are two parallel lines. They'll never meet each other. We didn't get an answer like this in this case. But the dependent system we did. That was the first answer, right? It's where, for instance, two cars are following each other. You're wondering at what time were there at that particular location that you're wondering about. So does that give you a rough picture for this? Once again, there it is. This is what we got. Dependent systems was the car following a car, and then consistent systems, single intersection points, where two lines meet each other or intersect each other at one location.